do you guys think? True or false? It's true. A function crosses a vertical line at exactly one time. That is correct. Number 2, the first number in the t-table corresponds to x. True. True, that's an input-output table. The first number always corresponds to x. Okay. The problem number 3, with the coordinate 6, 2, first move to the left 6. First number tells you to move left or right. It's positive, so move right. Second number tells you to go up or down. Number 4, the following sets of ordered pairs represent a function. Another way to look at these numbers is like this, too. -1, 2, 3, 5, 4, 2. There's 1. If there's ever the numbers over here, these two numbers are different. They can match here. That's fine. It's when you have one input with two different outputs that would make it not a function. These two right here are the x values, right? These are your y values. It's okay if two of these have the same y. It's when one of these here has two different y's, then it wouldn't be a function. Okay? So the following sets of ordered pairs for A is true. Okay, for B, if you look at that, every x do you notice that one x appears twice? Do they have the same y value?
No.
Okay, so that's when I'm letting you know. If this number has more than one y, that makes it not a function. So this one would be false. Because 0 cannot have two different y's.
Oh.
That makes sense? And here's another way to look at it. So 0, 0, -2. Those are all the x values, right? Yeah? And then the other values are 0, 7, and 4. 0 goes to 0, but then 0 goes to 7. Right there it went to two different ones. Yeah? It's the same number, isn't it? So technically then, we could do this. We'd only have to write the 0 once then. And we would have, it's when you see this. The input has two outputs. That's not a function. A function only works out when there's only, you get an input and one output that goes with it. Okay? If you put a different input and it gives you another number that's the same as a previous one, that's okay. It's when one input gives two different outputs. That makes it false. You with me right there? Yeah. You guys are going to be asked about functions. Do you understand functions? Does everybody remember the vertical line test? However the graphs look, a line vertically should be able to go through it and touch each point on the graph once. So we'll take a look at that with that first handout that I had you guys pick up. That's the one with all the red graphs. And we'll determine which ones are functions, okay? Okay. So T-table and XY chart are identical, so that one is false. Another term for input-output is XY chart. True. The domain corresponds to the Y coordinate. You are going to need to know that. You will be tested on that. All of the X's are your domain. All the Y's are your domain. Not corresponding. Range. Put that in your notes. You're going to be asked this. Domain and range. Okay? What's the domain and range of an input-output table? All the X's are the domain. The range, whatever the Y's tell you to do. Okay? So for number 8, the domain corresponds to the Y coordinate, true or false? False. Number 9, X is to output as Y is to input. It's false. It's switched. X is to input and Y is to output. It's false. All right, which of the following are functions? A. Function, true or false? A linear equation, as long as it's not x equals a number, is always a function. This has a y-intercept of 9. So go to the y-axis at 9, draw a dot there. Has a slope of up 4 to the right, 1. That would be a line going uphill, which if you do the vertical line test, and I'll show you in a little bit, it is a function. Every point on the line touches a vertical line only once as you scan it, kind of like a laser. So this one is true. All right. D, is that true? All right. Are any of the B's repeated? Which one?
Oh, okay, because the one was negative, the other was positive.
Okay, so those are two different. Yep, those are two different. Now, this would have been a positive one, and this would have been a positive one. Then we'd have two different outputs. That means what? Function or not? Not function. If it was two positive ones, yeah? But this is clearly a different, and then this one, right? So there's three different numbers here. Right. And of these three different numbers, okay, two of them could have the same y value. That would be okay. It's when the same number here has two different y's. Remember? So function. Okay. All right. So just a little. Kind of get your brain started. What did we talk about right now? What were the main things? Can you tell if something is a function? And the other one is one of the parts that you're going to be testing. Domain and range. Okay? Now we'll go over those. Okay? Yeah. So far on those, everybody okay? You figured out will give us that table of negative 10. Which one of these three did we have to use first? Bottom one?
No, the middle one.
Middle one? Okay, we had to use g of x first, which meant we had to use square root of x. And x was going to be 16. So square root of 16 gave us 4. Correct? All right, which one did we choose after that? We already chose that one. What was the next one we had to use? This one right here? Go ahead and choose that one. X squared minus x plus 4. And that gave us 4 squared minus 3 times 4 plus 4. That was 16 minus 12 plus 4. 16 minus 12 gave us 4. 4 plus 4 gave us an 8. Okay, positive 8. And the last one was f of x equals negative 2x plus 6. That was negative 2 times 8 plus 6, negative 16 plus 6, which gave us the negative 12. You guys have that working there, right? Yeah? Okay. All right, we're now, somebody came up to me and said they couldn't get a positive 6. Same problem? Yeah, I can get a positive 6? All right, so let's try, we want to plug in 10. All right. You realize if I plug in 10 for g of x, I'm going to get a decimal. So let's not plug it into g of x, yeah? So our options are going to be f of x or h of x first, yeah? So let's say we do the bottom one first. So let's do some side work here. 10 squared minus 10 minus 9, that's 100, minus 10 minus 9, that's 90 minus 9, and that's 81. Okay, that number, 81, is a perfect square, yeah? So then let's try to put it in here, yeah? So, square root of 81 is 9. And then we'll plug in 9 over here. Negative 1 times 9 is a negative 9. Negative 9 minus 3 gave us a negative 12. Yes? And I think I made a mistake again on that one. I'm almost positive in my notes. This is what I have, negative 9 minus 3 is minus 12. Now we'll try a different way. We tried to plug in 10 into h of x first, right?
We only did 2 problems.
So what I'm going to do is I'm going to plug in 10 to this one first.
But we didn't finish the last one. There's only 2 problems. Oh, no, my bad.
Yeah.
Sorry.
That's okay. Now, I'm pretty sure this is the input, or this is the value I was supposed to put on the handout. Somehow I put 6. But I'm going to show you what happens if we go the other way, okay? I'm not going to do this one first. Does everybody understand why I'm not going to do that one first? 10, square root of 10 is going to give me a decimal. And I wasn't trying to make it that difficult for you. Okay? So we're going to go with this one first then. Okay? That would make that negative 1 times 10 minus 3. That's a negative 10 minus 3. That's a negative 13. Right there, that negative 13, I can't even put it in here because you can't get square roots of negative numbers, right? So I'm going to go right here to this one then. Negative 13 squared minus 13 minus 9. Negative 13 squared, I believe, is 169. You guys can check that on your calculator. Plus 13 minus 9. 169 plus 13, that's 179. 182. Is that right? 182 minus 9. 173, or 174, wouldn't it? 173? No, 182,
Wait,
What?
because 9 plus 3 is 12, yeah.
173. 169 plus 13 is 182, is that correct?
169 plus what?
13 is 182? Yeah. Okay, so I'm good right there.
How'd you get to 13?
We chose this one first instead. So we plug in 10 to that function first. You see that we plugged in 10 to this one first last time? And this is the output I get after I go with this one, and then this one. Now I'm going to show you a different one. I'm going to do this one first. And I'm plugging it into here, and then I'm hoping that number is a square root. Square root of 173, I believe, is a decimal. Yeah. 13.8.
13.1.
The only other option I have is start off with this one first, right? Which will give me a decimal. And then that decimal would follow into the other function. So my typo was right here. The typo right there should have been a -12. When you got the -6, I think you got this one, didn't you? And maybe I just was going so fast that I saw -9 minus 3, and I looked at it and I saw 9 minus 3, not -9 minus 3, which is 9 minus 3 is 6. But that's not what you get. You get -12. All right. It says state the domain and the range of the graphs. I didn't put a graph here yet, so just right here. Domain, what does the domain represent? All the x's, right? So everybody take a look at the letter B. What is represented on the x-axis on this graph? What is it? Days of the week. So the domain is all the days of the week? Are they all included? Yeah. Starting from Monday through Sunday. So the domain is Monday through Sunday. How about the range? What's the minimum y value that they use, and what's the maximum y value that they use?
0 to 50.
10 to 35.
0 is on the graph, but it's used as a reference point. 0 is not part of the range. 10 is the minimum y value on the graph.
Because the graph lies on it.
The lowest one point is this point, right?
Yeah.
That's one. And which one is the highest y point? 35? Yeah. Your range is between those numbers. Can you see that on the graph? Range is between only those numbers of the graph. Okay? So range is between 15 to, oh sorry, 10, 15. If we were to put 15, that would be more common because there is a number lower than 15. Okay? And we said 35 is the maximum y value that is used. Now, when you guys are stating domains and range, the unit for this section for Algebra 2 has 2 quizzes on it, okay? We want to take the first quiz on Thursday, okay? And then we'll review a little bit. We want to, next week, we want to get through the second part of the quiz work. And I want to have the first unit of Algebra 2 to your teacher in less than 2 weeks. Okay? Yeah. So far from all the stuff that we've done, you guys remember when we first started, the first day we did all the graphs? First day I tried to tell you, okay, you try to do it on your own without anything, right? Then we did the graphs on the calculator. You guys, every day you're reminding me to do these, okay? Now we're looking at all kinds of graphs, and now you got to remember, is it a function, okay? What's the domain and the range, okay? Now, the one we just did right now, that probably was a little review for some of you. You might have forgotten domain and range, and that's okay. That's the whole point. We're just trying to review everything as much as you remember, okay? All right. There was another graph here, but the copy didn't put it out, so that's okay. Let's move to number 3. All right, take a look at everybody take a look at the red graphs. Okay, first one, linear function, y equals mx plus b. You guys remember that way back from a long time ago in algebra? Yeah? If you know the y-intercept, you guys can tell me what, you can go to the y-axis, put a dot there, and then the rise over the run. Yeah? Okay. What do you guys think the domain and the range is of this linear function? What do you think? When you're looking at it, what's kind of hesitating for you guys? What are you not sure about? Is there anything that makes it confusing? The domain and range for you? Yeah.
Well, it doesn't say like, there's like numbers on one side, and then it'll tell you like Monday through Sunday or whatever.
Okay,
like,
good.
This graph was.
Good point. Did everybody catch that? Now there are units labeled. Does everybody agree? Here's the thing about these linear functions. Everybody do me a favor. Do these 2 little symbols on the ends of the line for me. What are those 2 little symbols that I just drew mean? It goes on forever in both directions. So will this drawing ever really end? Will it ever go all the way to the left of x? Because remember, a point on the line is a solution, right? The coordinates of a dot, let's say this dot is -2, -2 about, right? Will I ever use x coordinates that are way to the left, like -100? Eventually, yeah. Now, could I write the equation of this line? Well, it looks like it goes through 0, 0. It looks like it has a positive slope. This looks like the equation of y equals 1 over 1x plus 0, or y equals x. If I were to plug in x equals -100, the y value that goes with it is -100. What if I put in -1,000,000 for x? Y would then y would be -1,000,000. So is there a limit to how many x's I could actually have coordinates for on the left? No. So that means all the possible numbers on the left of x, or the left of 0, should be more specific, right? How about to the right of 0? Is there any limit? No. There's no limit, right? No restrictions. Every number that you can think of on the x negative, and every number that you can think of on the y on the x positive can be used if you did an input-output table. That means the domain here, all real numbers on the x. How about the range? Same thing. Because the negatives are going to go forever, and the positives are going to go forever. So the range, all real numbers. Okay? Take a look at the next graph. That's a quadratic equation. Do you think that this graph is just going to keep opening up forever and ever and ever? Eventually it'll get so wide, way up in there, right? Will I ever have an x coordinate that's negative, that's way over there, that has a y coordinate up here somewhere? Okay. How about on the positive side? Big positive x will give me an even bigger positive y. The graph of this parent function is y equals x squared. Okay? Notice they're all at the origin. Remember the parent functions I was talking about? These are all of them. Okay? What would be the domain then for this problem? Start thinking, guys. Domain. All real numbers. Because any x that you think negative is going to have a y value up here, right? Any x that's positive is going to have a y value up here. So the domain all real numbers. If you use this R, that means all real numbers. This one right here. If you use the R, mainly with the two bars right here, like that on the left, that's the texting code for saying all real numbers. Right? Okay. What's the range of this quadratic? Does it include all the negative y's? Where does the minimum y's begin? Where? At 0. So from 0, and then does it go up or does it go down? Up. 0 to positive infinity. Infinity means what? Forever. So 0 to positive infinity. Does everybody see that the range is from here? And it just keeps going up that way? All right. I want you guys to try to figure out what is the domain and the range of a odd degree polynomial, any polynomial that's to the third, fifth, seventh, or the 2n plus 1 power. All polynomials that are to the second power or even, x squared, x to the fourth, x to the sixth, or x to the 2n, those are quadratic, okay? Go ahead and see if you guys can write down the domain and the range for an odd degree polynomial. I'll give you 1 minute. All right, the next one. These are even roots, okay? Now, square root of x does not necessarily have to have the 2 there. You could just write it like this, okay? That one and that one are the same thing, okay? Square root of x. Do me a favor. Square root of x is also the same as saying x to the positive 1/2 power as an exponent. Okay? The fourth root of x would just be x to the 1/4 power. The 6th root of x would just be x to the 1/6 power. Yep. Okay. Here, this graph only goes forever that direction, not the other direction. Okay? Does everybody see that there is a clear stop right there at the origin? Somewhere it starts right there, and then it goes. Okay? Could you get the square root of 0? Type it on the calculator. See what it gives you. Square root of 0.
Or how about you ask Siri what 0 divided by 0 is?
That's different. Anything divided by 0, you could do 1 divided by 0. You can never do that division. It doesn't exist. There is no way to go through that. If you ever use 0 on the denominator, it causes a problem in math. Okay? Remember when we start using the graphs that have the 1 over something on a fraction, and it's like x plus 2 or whatever? We can't ever let the denominator be 0. That's when we start having those asymptotes. Because there's no, you can't do division by 0. Yeah? So if you ever ask Siri, just say anything divided by 0, it's going to tell you, not possible. There is no way you can do that division. Yeah?
I think it's pretty funny though, because it starts talking about like something about the Cookie Monster. It says you're an idiot or something.
Oh, okay. All right, cool. All right, so if you type in square root of 0, you should have got 0. Yeah? Do me a favor, type in put a negative number in the square root. See what it says when you do that. If you type in square root of, and you have to use this negative here. You know square root of 9, right, is 9, or 3. If you do square root of negative 9, it says quick error. Here's the statement. Non-real number answer. Those numbers don't exist yet. I haven't taught them to you yet. Okay? Look at that. Square root of, square root of 0 gave you 0. 0 times 0 is 0. It will. Eventually I'm going to show you how to do square roots of negative numbers. But that's called the imaginary math. We'll start doing that. We are going to do imaginary numbers. Okay? You guys, this is the first time that you, in math, at your level, that's when you see imaginary numbers. Numbers that don't exist. Okay? It sounds kind of weird, because then you start getting into some really weird math. I like it, but some people are struggling. Now, you guys remember these parent functions that we did? Remember how we could tell, oh, this moved it to the right 7 and up 4? This one moved it to, because that negative's right there, it's going to change that. It really moves it to the left to the up 6, and then this stretches it or widens it, or narrows it or widens it. Say it again. Exponent is just a quadratic equation. It's a parabola going up. Now, if that 2 would have been negative, the parabola would go, yeah. These are the ones we already did, yeah? Okay. All right, so now, take a look at the root functions that are even. What do you think the domain is for these? What's the domain? Is there a, can I do all the x's to the negative side? Right yonder, you're shaking your head. You see that there's some point that there is no, it clearly doesn't show that you can go further to the left of 0. So that means the domain starts where? At 0. So from 0 to what? Positive infinity. That one. And does everybody understand that infinity symbol is just the 80 sideways? And there's infinity positives and infinities that are negatives. Yeah? All right, how about the range? What's the range? Same thing? On the range, remember, the range is referring to the y-axis. At 0 to positive infinity. Now, when I put those little marks there, you guys understand those marks represent the exact same thing that was written just above? Yeah. I think they teach you that in English, don't they? No? No? Okay. All right, what about the range of odd roots? What's the domain? Or the next one, what's the domain? How do you say it? Domain is all real numbers because all the x's that you're going to choose will eventually have a y value. And all the y x's to the right are always. So the domain is all real numbers. You see that I'm starting to just use abbreviations? D means domain. Yeah. I didn't do that from the beginning though, did I? I just kind of let you gradually get into it because now I know when you say this, what about the range? All rails. Because any x, any y value, it's going to keep going down. This graph goes forever. And it's not going to end right here. It's going to keep going down. It's going to take it a long time for it to reach these numbers down here. But because it never ends, it will get there. So the range is all reals. Yep. All right. How about for the next one, which an odd degree polynomial? That's an x to the third, x to the fifth, x to the seventh power. What do you think on those? What do you think the domain is? Is the domain all real? DeAndre, what are you thinking when you? Because I know you're hesitant to say it's all reals because you know there's something that's restricting or something's messing it up. At 0, there's something is messing it up, isn't it? Remember what the line, this line is called? It's an asymptote. There's an asymptote here. And there's also an asymptote right there. At 0 on the x and at 0 on the y, it's never going to touch those points. But it's very clear that to the left of x, I can pick x value and it'll give me a y value that goes with it. So I can say that the domain is from negative infinity to what? If I start at negative infinity, from negative infinity to 0, not including 0. Because remember, when you're going from left to right, you're going to have to stop right here because there's a break there. So from negative infinity to 0, and then from 0 to positive infinity. There's an asymptote right at 0. It's never going to have an x coordinate of 0, comma something. Okay? How about the range? What do you think the range is? Can I go all the way to the bottom of negative infinity? Yeah, I'm going to have a y value that's going to have a negative infinity. It's got an x value that goes with it. What happens as I move up closer to the origin, though? There's a stop here at y equals 0, right? There is never going to be a coordinate that has y equals 0 with it. So the range is going to be from negative infinity to 0, and from 0 to positive infinity because of this asymptote. Asymptotes, remember, are lines that the graphs can never touch. It's kind of like a force field. Asymptotes are like a force field. You can never get through them. Okay? Be getting into these types of functions. See if you guys can get the domain and the range of this 3 right here. Okay? While you're doing that. So even powered, now these are our fractions. 1 over, this is the parent function of y equals 1 over x squared, or you could say f of x is equal to 1 over x squared. Okay? This will be the parent function of y equals 2 to the x. This is exponential growth. And over here, this is y is equal to 2 to the negative x. This is exponential decay. You did see this previously before. Exponential growth and decay you guys should have seen at one point before, okay? But we're going to touch more upon those, okay? All right, who can tell me the domain of the first one? Somebody's got to be able to tell me. What do you think, Nancy? Remember, domain represents which axis, the y or the x? All right, so now think. I go forever on the x-axis this way, and there'll be a y value that goes with it. Okay, that's fine. Let's just first get a starting point. We can keep going to the left of x, right? And there will be a point that there is a coordinate that has a negative a millionth x and a y value that goes with it, because this graph does go forever that direction, yes? Right. So it does go from negative infinity. Let's go from negative infinity all the way to what point did you start to see something wrong on the x? Only on the x. When I started coming over here, where did you see a problem? By the 0. Because at x equals 0, it looks like this is going to be an asymptote. Yeah? You notice that if we ever plug in 0 for x, 0 squared is 0, right? What's 1 divided by 0? Can't do that. Can't do 1 divided by 0. There's an asymptote. So from negative infinity to 0, it reaches a point where, okay, you've got to stop and it's a jump there. Yeah? And then what happens when I, remember, domain is all of the x's, right? So what about this way? From 0, you start, but not including 0. From 0, then you can keep going all the way to positive infinity. Yeah. Even at a small number right after 0, there is a y value way up here somewhere that goes with it. Now, at one point, somewhere after 1, the numbers get closer to 0. Okay? All right. That's the domain. A range. That's the range. Okay?
Just 0.
Okay, 0. So you're saying nothing below 0? Does everybody agree there's nothing below that 0? So from 0, which direction? To positive infinity. The range is from here, going forever there. Nothing below 0. There's nothing below 0. Yeah? Did you see that the domain was a little bit different? Because there was a gap there because of the asymptote. All right. And for exponential growth, so what do you think? Will we be able to go all the way on the x-axis forever that way? Yeah, you'll get a point. So from negative infinity to, could I ever, this is the graph of y equals 2 to the x. Could I ever say y equals 2 to the millionth power and get a y value that goes to it? Yeah. So that's domain is, and let me put that T over here. The domain is all real numbers. How about the range? Does the range include all the numbers? Or do you see it doesn't include some numbers? The negatives? Does it include any numbers below 0 on the y-axis? 0 is actually going to be an asymptote. Because this line looks like it's going to touch the x-axis, right? But remember, it's just getting so close and close and close and close and close. It looks like it will touch it, but it's never going to touch it. So the range is from all the numbers that are above 0 on the y-axis to what? Positive infinity, because there is no end to how high it's going to go. Yeah? So from 0 to positive infinity. And eventually I'm going to start getting you guys to see how this texting language really works. I'm just kind of getting into it a little. Okay? So far we're okay? Are there any questions? All right, can everybody do the last domain and range for me, please? Okay, domain and pretty agree, all real numbers. Because you can think of any x number all the way to the left. Okay. And you can go all the way to the right. Can x be 0? Yeah, 0 comma somewhere right there it does have a coordinate. And the range is from 0 above, not including 0 because 0 is an asymptote actually. Okay. All right, do this handout. Can everybody go back to this handout? Okay, so you know what the graph of y equals square root of x looks like, right? It's on your cheat sheet right now. Go to your cheat sheet to y equals square root of x. The one we were just on, y equals square root of x is on your parent function list. All right, we're going to type in y equals square root of x plus 5 on your calculator. So go ahead and turn on your calculators. I would, before we do anything, I would hit the second button, the plus button, reset, 7, 1, and 2 to reset the memory, just to clear everything up, and then you hit the clear button. All right, everybody go hit the y equals button.
You went too fast to clear you.
So you should have hit second, the plus button, look like this. I have it on the screen. hit 7.
Oh, what's going on here?
Okay.
We'll do anything.
All right. Everybody hit their Y equals button? All right, go ahead and type in the second function, then hit the square root symbol, and inside it's only going to be x. Now next, remember, don't type in +5 because it's going to include it into your square root function. Go ahead and hit the arrow button to get out of it. Everybody see that? All right, now go ahead and hit +5. And take a look at the bar should not extend the whole way on when you input it. Go ahead and hit graph now. Take a look at the parent function of y equals just square root of x. It's at the origin, right? Y equals square root of x is right over here. And this is the original y equals square root of x, okay? Remember we went over this. What's the domain of this one? You guys who did it, you have the domain and range.
Oh.
0 to +infinity.
0 to +infinity is the domain. What's the range?
Same thing.
Same thing, 0 to +infinity. What happened now with this graph then? Y equals square root of x plus 5. What did it do? It moved it 5 units up only. Yeah? So this graph just went up 5 units, so increments of 1, 2, 3, 4, 5. That means the graph now is right here starting. And it's basically the same graph, just shifted up 5 units. Okay. All right, let's go ahead and type in, hit your Y equals button. Let's go ahead and leave that one there. Scroll down 1 so you're on the Y2. Yep. Go ahead and hit second square root. And now we're going to type in x plus 5. The square root bar should extend all the way across. Do you guys see the difference there? Yeah. Go ahead and hit graph now. The first graph you guys did is already there, okay? The second graph, when you hit it, should start popping up. Okay. Everybody see your new graph? So take a look at your original parent function. Remember our original parent function was this one right here? I'm going to put it over here. This is the original parent function of y equals square root of x. What happened now? We went to the left 5 units. That's all it did. So here's the origin. The domain and the range is all real from 0 to positive infinity on the domain. The range is from 0 to positive infinity for the original one, right? The graph just shifted 5 units to the left. 1, 2, 3, 4, 5. You notice that this is inside the square root symbol? If you set that x plus 5 equal to 0, you get x equals -5. It's telling you shift it only to the left 5 units. If there would have been a number outside of here, plus or minus, that would have been up or down. Yeah? Alright, so you guys starting to see how some of these graphs from the original parent functions with that cheat sheet I'm giving you guys, how they're just being shifted left, right, up or down, or stretched or flipped, even if it's of a negative outside of it. Yeah? Alright. What would be the domain of this new graph then? This one right here. What's the domain of that one? Say again? The domain is from -5 to 0. 0 only has a coordinate right there. Does it stop there? To positive infinity. Because it starts here and it just keeps going that direction. Any x number between -5 and that direction, you're going to get a y value that goes with it. Okay? Do me a favor. Go to your calculator real quick. Remember that our y1 is the square root of x plus 5, right? Okay, do me a favor. Hit the blue button or the second button. Oops. Hit the blue button. Now hit the graph button because we want the table of values. All right, everybody see the table of values? The y1s all represent the first equation that you graphed. Okay? Do me a favor. Scroll up a little bit. Remember, you notice that on the very first graph over here, it says when x is -1, it says error for the first graph. When x is -1, there is no y value because the domain says only from 0 to positive infinity. You see how you can figure out the domain on the calculator? Alright. Now go ahead and let's take a look at the domain on the second graph that we just did. Should there be an error after -5 going that way? Go ahead and scroll up to where -6 and 7 would be. You see the second one? That's when it starts having errors after -5. When x is -5, y is 0 technically, right? But after -5, there's errors there. Yeah, that's because the domain is from -5 to positive infinity for the new. Okay. Now the range. What's the range? From 0 to positive infinity for this one. So the range here is. The range is from 0 to positive infinity. You guys getting this idea of domain and range? Those of you, if you're not speaking up, I need you to understand we will be tested on this. We do want to take this quiz next Thursday, okay? Because I want to get Unit 1 of Algebra 2 to your teacher within less than 2 weeks, okay? Yeah. It's just there's 2 quizzes to the Unit 1 section. Okay? I'm trying to take my time because I want to make sure you understand domain, you understand range, you understand how to input the graphs into the calculator. You guys see how to read the table of values to help you use that for domain and range? Yeah? Okay. Right. On these tests, they are going to be specific types of questions. So look at this. Use your graphic calculator to help sketch the graphs. Okay, you guys understood how to do that? Now, are the graphs the same? Clearly they're not. And you guys see the differences between the two? Should they be the same? Well, no, because this one did not include the +5 inside of the square root. That means that's a shift that's going up or down, depending if that would have been a -5, then it would just shift it down. Yeah? Over here, because the x plus 5 is inside of the radical, it's shifting it left or right. Outside of the radical to the right is shifting it up or down. Okay? Then it says, explain clearly why the graphs should or should not be the same. Be sure to justify your reasoning using multiple representations. So this is where you guys, your thinking has to be translated into a sentence. Okay? So let's scroll down. All right, so explain why the graphs should be or should not be the same. So you guys have to start becoming more observant of what you're thinking and being able to express what you're thinking. Okay? This is where a lot of you guys that I know you're shy and some of you guys are kind of quiet, but you got to start raising your hand to participate. All right? Sketch a graph with a domain of -4 less than x and x less than or equal to 2. Now, when you're reading that, the domain represents what axis? X. So do me a favor, everybody go to the x-axis and find a -4. Place a dot there.
-4, 0, right? Just on x.
Just on the x, on the domain. Now, should your dot be open or closed? Open. So here's -2, here's -3, here's -4. Put an open dot right there. Now, do you guys remember back in algebra? Open dot because the inequality doesn't have an equal bar underneath it. So our domain is from -4, but not including -4, all the way to what? All the way to 2. Closed circle or open circle at 2? Closed. So go ahead and go to 2. Closed circle there. So here's your restriction. You can only draw a graph and your graph cannot touch that line. Okay? It can touch this line though. That's your domain. You're restricted then. It's kind of like you guys, your parents have rules for you guys. Say, hey, you gotta be home between this and this time, or something like that. Okay? So the domain is telling you a restriction. You have to have the graph somewhere in between here. Okay? Now the range tells you the next part. What's the range giving you restrictions on? Let's start to get more people participating because part of your grade is going to be participation. Okay? So go to the y-axis at -1, open or closed? Closed. So that means I'm going to include anything right there. Right. And then, how far can I go up? 4. Closed or open? 3, 4. That's a dash 4. And does everybody see where you're restricted now? Your graph can only be in this little square. Everybody draw a graph of one of the parent functions that we have talked about in that little square. Or you could draw any graph you want. Is that graph a function? If it passes the vertical line test, every point touches it only once. As I scan it left to right, every point will only touch one time only. So that makes it a function. Now what if somebody would have drawn something like this? Inside this little box, what if somebody drew something like this? Or, well, they can't go outside of that box. Just imagine this is in here, yeah? It is a graph. It says sketch a graph with the domain between here and here, and that would be justified. Now, is it a function? Vertical line, there's twice. The minute it touches vertically twice, not a function. Yeah? Okay. Now, could that have been a sketch of a graph to answer this question? Yeah. Because all it said was, just sketch it with these restrictions. Does that make sense? Did you understand why this line was solid and why this one was dashed? The reason why this one was dashed because that point could not be used as part of the graph because of the symbol dissimilarity. So here's a quick review of that. Those are the four inequalities, correct? Yep. Those four inequalities have these characteristics. These two are always open dots. And because they're always open dots, they're always going to be dashed lines because they don't include those points. Okay? You guys remember that from algebra? These two always have closed dots, and they always have solid lines because any of those solid dots are part of the line. So if you see this one's solid and this one's solid, this one over here is dashed and this one's dashed. However you would have drawn the graph, you just can't let it touch this line and that line. You could have let it touch this one down here and this one right here. Does that make sense? Okay. All right. Type it in your graphing calculator, sketch the graph of it, and then I want you to tell me anything you notice about the graph. Does it have any intercepts? Are there any important points that need to be labeled? Because it's a quadratic equation, there are important points. Now, if you're not sure how to type it in on the calculator, okay, take a look up here and I will go through it step by step for you. Go ahead and hit y equals and clear the two equations that we had already typed in. Clear those out, okay? We don't want those there. Scroll back up to y1 so we can type in there, okay? All right, so if you're not sure how to type it, take a look up at the screen so I can show you step by step, okay? Are you ready? All right, first thing is x. Next thing is we're going to square it. So we're going to hit the second button, and we're going to raise it to the second power. It should be there. Oops, no. Second button, and I'm assuming it's that one. No. If you did that in there like I did, hit delete. Where's my square button? That should be right here.
Don't you have to hit the arrow thing to make it go up?
It should just be my second button. Oh wait, no, I don't even need to hit the second button. I just hit. Oops, that's wrong. X. There it is. Sorry about that. My screen is a little blurry, so I can't see. This one is x squared. This one I'm assuming is x to the negative 1. Yeah. Okay. All right. So you okay right there? Yeah? All right, so then we have to hit plus then our x again, and then don't use this negative, okay? Use this minus. Okay. Are we okay right there? Yep. Go ahead and hit graph then. There is our graph. Go ahead and sketch the graph of on your paper, please. Please label your points on the calculator. These are all increments of 1. So all you got to do is count. So somewhere in here after 2, it looks like the calculator doesn't touch right at 2. It's between 2 and 3 it's going to go through. Okay. And then over here on the left, -1, -2, -3. So -1, -2. Between -3 and -4, that parabola is going through there. Okay? So somewhere there is a point that it's going to touch somewhere between those. Those are decimal values. All right. And then the parabola does have another intercept on the y-axis. Does everybody see where on the y-axis it kind of looks like it touches? Somewhere around -8. It seems like it's just before -8 though, yeah? Okay. So I'm going to count. So that's -2. That's -4. That's -6. And that's -8. So it looks like it's touching it somewhere just a little bit above that, I think.
To the left.
To the left of it?
Like, from
Yeah, just to the left of it a little bit more. Okay. Now, if you look at this point, what's this point down here called?
Vertex.
That's the vertex. So you need to label the vertex on the drawing. Okay. So the vertex, notice that the vertex is a little bit lower than that y-intercept. So I'm going to draw my vertex somewhere right here. Parabola is going. This is a rough sketch, by the way. It's not going to be perfect, okay? So now you got to label anything you notice about it. Well, I notice 2 x-intercepts, and I'm going to label them. I notice 2 x-intercepts. What else do you notice?
Can we like list the domain?
Yeah, you can list the domain. I'll put that over here on the bottom. I want to list anything that touches the x, y axis and the vertex first, since I already started it like that. But you could have started domain and then. Anything else? I got x-intercepts. There's 2 of them. Clear? Any other intercepts? There's one on the y. Somewhere right there, right? I don't know exactly the coordinate. There's one arrow. That's a y-intercept. One y-intercept. There's also another point that's important that's called the left. The vertex. That vertex is also considered a minimum. And the reason why it's a minimum is because the problem is going down, 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 and then right at the vertex, bam, it reaches its lowest points, and then it starts to jump back up. Yeah? If the parabola was going down, then the vertex would be a maximum because it's going up, 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 like if it was a rocket. Up, 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 reaches its highest point, runs out of gas, now it's going to come down. Yeah? Vertex Minimum, maximum. Okay, now state the domain. What do you think the domain is? Domain is all real numbers because any x values that you can think of on the left and any x values on the right are going to have some type of a coordinate. Okay? How about the range? Now, what if you're not sure? Go to your calculator. What should we do on the calculator to try to help us with the domain and range? Not trace. We can go to what? The table. Hit the second button. Hit graph. Oops, I need to turn it on. Hit the second button. Hit graph. And you see at -7, there's a coordinate that goes with it with y, right? So I need to go down more. So. Oh, wait. These numbers are going this way. So we need to look at the numbers on the y value. Okay, right there. I was looking at the x. That's the domain, isn't it? I needed to pay attention to the y values because that's the range. You see on the y values, it goes down, 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 and then where does it jump back up? Where do you see two numbers identical? -8. So when x was -1, the y value was -8, right? And when x was 0, the y value was -8. That means the vertex is somewhere between 0 and -1, comma, between these two. Okay? So that means now go ahead and go back to the graph and now hit the trace button. All right. The domain, the range, notice that the lowest point, at least in my picture, it goes down to -8.24. Now, some of us are going to be off a little bit depending on if you zoom in or out. 0.42? Oh, okay, on the x, but I'm looking at the y value. That's because of this right. Yeah. Because remember, we're talking about the range now. So notice on the x value between 0 and -1, the vertex is somewhere right here, isn't it? Yeah. And you notice that the y value doesn't go any lower than -8.24. So that means our range, if we're not gonna be super specific on the range, we could say the range is somewhere about -8.24 to positive infinity. Because below that, -8.24, there's nothing there. That's part of it. Now remember, this is kind of a rough guess too, okay? Make sure you guys sign in. The sign-in sheet is right here. There's a little desk here when you come in, right by the door. Get one of those handouts, please.